Hello and welcome back. Today's video is the second in the series of data structures videos that we are looking at, and it is going to be about linked lists. Linked lists are similar to arrays in most of the ways because it allows to store a list of items, and the items can be of any data type like numbers, characters, or strings, and it is also a linear data structure, meaning it allows to store the data sequentially one after the other. However, the major difference comes in the memory allocation of the items. Linked list items need not be consecutive, whereas in arrays we saw that the elements have to be consecutive, that is, they have to be right after each other. So, in case of linked list, each value is stored as a node, and a node will have two sections. The first section will store the item's value. Let's say we are storing a list of numbers, then the first section will store the value itself, whereas the second section will store the address of the next node, which is called as the next pointer. Similarly, the second node will store the value itself and then the address to the next node. And once you reach the end of the linked list, then the last node's next pointer will be pointing to null, which indicates the end of the linked list. The first node in a linked list is called as the head, and the last node in the linked list is called as the tail. Let's see how this will actually get stored in the memory. Consider this as your memory board where each square represents an item. Let this be our first item. Then the second item need not be stored right next to it. Instead, it can be stored in one of the free memory blocks. And the first item will have a reference to the second item. It will store the address of the second item. And similarly, the second item will store the address of the third item. So let's say the third item is stored somewhere here. Then the second item will store the address of the third item. And since the third item in our linked list is this last one, this will be pointing to the null value indicating the end of the linked list. So this is how a basic linked list look like, and this is also called as the singly linked list because there is only one link between each of the nodes in the list. And also you can traverse only in one direction, that is starting from the head to the tail. And also notice that you can't access any other middle element in the linked list directly. Each linked list will have access only to the head element in case of singly linked list. If you want to access the second element in this list, then you have to start traversing from the first element, that is your head, and reach to the second element in the list. Alright, so these are the basics of a linked list. And there are various types of linked lists. The one which we discussed so far is also called as a singly linked list. And the second type of linked list is doubly linked list, where in addition to the next pointers in each node, there is also another pointer called as a previous pointer which points to the previous node. So the diagrammatic representation will look something like this, where each node has three sections. The first section is called as a previous pointer, and the second section actually contains the value that needs to be stored, and the third section contains the next pointer pointing to the next node. So when we say a pointer, that's nothing but the address of the next node. So it looks something like this, and you will have a pointer pointing to the head, and also there will be a tail pointer. And in this case, you can traverse both in the forward direction as well as in the backward direction, because you will have pointers pointing to both the head as well as the tail. So you can either start traversing from forward or from the back, and both the tail and the head will point to null values in case of next and the previous pointers. So this is doubly linked list. Finally, there is a third type of linked list which is called as the circular linked list. And in case of circular linked list, you can convert both singly or doubly linked list into circular lists by simply adding a pointer from tail to the head. So if you have, imagine this is your singly linked list, you will have a pointer from the tail pointing to the head. You can go in loops within this list. Every other property remains the same. So if you're using a singly linked list, then you can only traverse in one direction. If you're converting a doubly linked list into circular linked list, then you can traverse in both the direction in loops. So these are the three types of linked lists. Okay, I have made some space. Now let's quickly see what are the various operations that you can perform on the linked list and the time taken for each of those operations. And we are going to discuss this for both the types, that is singly linked list and doubly linked list. And in case of circular linked list, whichever one you're using, like either singly linked list or doubly linked list, is actually converted into circular linked list. So one of these will apply to the circular linked list as well. So the first common operation that you perform is accessing the elements in the linked list. And there are three types of elements that you will aim to access. The first is the head element, and then the tail element, and finally some node in the middle of the linked list. So in case of head, it takes O of 1 in both singly linked list as well as doubly linked list because you have direct access. And in case of tail, you have to traverse from the head to reach the tail in case of singly linked list. So it will take O of n time complexity if there is n elements in your linked list. Whereas in case of doubly linked list, you have a direct pointer to the tail element, so you can access it in O of 1 time. And in case of middle element, it will at most take O of n time because you have to start traversing either from the head or from the tail to reach the middle element. You can't directly access the middle element in case of both singly linked list as well as doubly linked list. So we say that it takes at most O of n time. And the second operation that you can perform on linked list is inserting a new element. And similar to accessing the element, you can do that at three levels of nodes, that is head, tail, as well as middle element. In case of head element, it takes O of 1 time for both singly linked list as well as doubly linked list because you have direct access. You can insert a new node at the head position and make that as the head and point it to the older head, and the same can be done for the doubly linked list as well. So in both the case it is O of 1. So in case of tail node, for doubly linked list you have direct access to the tail, so you can insert next to the tail element directly with a O of 1 time, whereas in case of singly linked list you have to first traverse to reach to the tail node and then create a new node from the tail and insert a new node. So the traversing will take O of n time and insertion is a O of 1 operation. So we can round it off to O of n time complexity. And in case of middle node, inserting in the middle, singly linked list as well as doubly linked list will take O of n time because you have to traverse and reach the middle node first, and then you can insert a new element. And the same thing applies for removing a node as well. And the final operation that we are going to look at, searching the element in the list. And for this, both the singly linked list and doubly linked list takes O of n time because you have to start from the head or tail and traverse through the list to search for a particular item. So these are the various operations that you can perform on a linked list. To point out a real world example for each of this linked list type, consider a music player and you have a playlist of songs. Imagine that you can skip to songs only in the forward direction, that is, you can only do next but not previous. Then that type of implementation is a singly linked list. Whereas if you can go both to the next and the previous songs in the playlist, then that is a doubly linked list. And if you run the songs in a loop, that is, if you run it in a repeat mode, then it will fall under circular linked list. Hope you found this useful. If you have any questions around linked lists, please leave them in the comments below. See you soon in the next video. Thank you.